Me? Alrighty, good morning guys. We'll go ahead and get going. So today guys, we're going to go ahead and finish up the 11-1 notes. We don't have too much to still go over, so you guys will probably end up having like 20 or 30 minutes of time to actually work on the homework. So hopefully you guys go home without having any homework to do, which would be nice.
Oh wow.
Can we play like fast?
Alright, so let's go ahead and get going. So guys, we left off, we had just finished classifying each figure. Guys, make sure we're listening.
We need to do
Yeah, so we just left off classifying each figure. We named the vertices, edges, and bases. I think we finished all the way through part B, right?
No, we didn't do it.
Did we go over it
I
yet?
only have cylinder.
We did not remember your
Alright, so yeah, let's go and go over it then, guys. Alright, so for part B. So first off, let's go ahead and identify what is the name of this figure. Brianna, what did you get? Yeah, oh, I'm writing in white. Yes, it is a cylinder. Alright, so now guys, we have to name, not just count them, not just, thank you sir. Alright, we have to name the vertices, and guys, I'm going to pause the restroom line until after we finish the notes. So we have to name the vertices, we have to name the edges, and then we got to name the bases. So, Ray, go ahead.
Is that a half sphere?
Yes. Alright, so Ray, go ahead and name the vertices for me, please.
Wait for
For
P and Q.
P and Q. Okay, so go ahead and do me a favor, go to the notes and read the definition of a vertex for me. So here, go ahead and read that out loud for me, please.
Vertex is the point that is the intersection of three or more faces.
All right, cool. So a vertex is the intersection of three or more faces. What's a face? Can someone tell me that? Yeah, Xavier?
It's the base of the shape.
The base of a shape. It could be. It could be the base of a shape. Christian?
It's like a side.
Oh yeah, it's basically like a side of a shape. All right, which includes the base. All right. So, do we have anywhere in this cylinder where three faces are all intersecting to form a vertex? Yes, sir.
There's no vertices and no edges, right?
Yes, sir. All right. There are no vertices, and there are also not going to be any edges. Can someone tell me why are there no edges?
And then the bases are P and Q.
We'll get there. We'll get there for the bases. Yeah, so basically, as when you think of an edge, so again, that's going to be where two faces basically intersect. All right? Well, so let's talk about that. What are you confused about, Arliss?
we have like base edge and then base, and I don't know like what we actually have to write down, because like if it's just vertices, base, and edges, for the last one, why do we put like lateral edges? Like, do we include that too?
Okay, great question. So Arliss is asking, why did we break this one down into lateral edges and into base edges, whereas this one we're just talking about edges? The reason is because this one had two different types of edges, so I wanted to kind of differentiate between the two different types. You know, edges that are basically along the base versus edges that aren't, which are those lateral edges. Whereas this one doesn't have any. So I could say lateral edges none, base edges none. Instead, I'll just say edges none. Oh, so good question. But so guys, and don't overthink it. You know, an edge, you guys know what an edge is. All right, if I gave this to any single one of you guys and asked you to point out an edge, you would just go anywhere that any of these two faces intersected at. And of course, so here we do not have any faces intersecting, so there are no edges. So earlier, Jake said that the bases are P and Q. Can anyone add to that, or did anyone come up with a different answer? Xavier?
I agree with him, and I think that circle is like the midpoint of the base to find the area of that face.
Oh yeah, we can get there in a sec. But so guys, I'll tell you, if you put down P and Q for your bases, you are wrong. Kyler, what do we have to add?
It's circle P and circle Q.
Perfect, guys. We have to add circle P and circle Q. Because if I only put Q, I'm not referring to a circle, I'm referring to a single point. If I only put Q, I'm not referring to circle Q, I'm referring to a single point. Yes, sir? Yeah, you could also write the symbol. You could have done that, circle P. Yep, awesome. Alright, and then so Xavier asked if this is basically the center of the circle. Yes, it absolutely is. And you know, if you were given like the radius or the diameter, you could go ahead and figure some stuff out with it. Cool. Anyway, we're waiting for the restroom line until we get through the rest of the notes. Alright, any questions on that, guys?
No.
Cool. Alright, so we have 2 more new concepts that we'll go over today. And then you guys will have time to work on the homework. Alright, so first up, guys, we have a cross section. So cross section, here's the formal definition. The intersection of a 3-dimensional figure and a plane. So you guys know what 3-dimensional figures are now. We've been working with those a bunch. A sphere, a triangular pyramid, a cylinder. What's a plane? Can someone please remind me, what is a plane? Brandon?
That's like the flat piece.
Yeah.
It sits on and crosses the,
Like, keep going?
the object, it sits on and crosses the.
Okay, so Brandon said a flat surface. Awesome. And I think you said that. I had a little, yeah. All right, a flat surface. Can someone expand on that? Christian?
Like, you know when, you have the X and the Y? It's like, one of those, only one though. Like if you have the X plane, it'll be like this, like that one. And
Okay.
then the Y plane, it's up and down like.
Okay, so Christian's gonna talk about we can have intersecting planes. We can have like a vertical plane intersecting with a horizontal plane. Does a plane end?
No.
No. All right, so that's kind of something to keep in mind. All right, so basically it's an infinite flat surface. So is this a plane or is this a representation of a plane?
Representation.
All right, cool, awesome. So guys, when we're describing each cross section, the cross section is the part that's formed by the intersection. So when we look at this example, let me go ahead and find it in my many shapes. All right, so here, guys, is a rectangular prism. And basically, a cross section is if you took your 3D figure and you sliced into it with a plane. And the cross section is the shape that's formed as a result. So guys, in here, the shape is that little green thing. So Delia, what shape is the cross section formed by this plane and the rectangular prism?
Rectangle?
Delia, your voice got a lot deeper.
Oh.
All good. But you are correct. It is a rectangle. All right? You're right. It's a rectangle. So literally, guys, when you're describing each cross section, all you're doing is you are, literally just describing. You're naming the shape. So, guys, what is the shape? Let me hear from Delia this time. All right. What is the shape formed by the intersection of this plane and this 3D figure?
Like the base or
So the cross section is going to be the shape formed by
like
this.
the tan thingy? The tan.
So the tan thingy, what is that? Is that the plane, the cross section, or the 3D figure?
The cross tan.
Okay. So where's the plane? Because so remember, a cross section is the intersection of a 3-dimensional figure, like a cone or like a pyramid or something. All right, and a plane. So in this picture, we've got 3 things. We've got a plane, we've got a 3D figure, and we've got a cross section. Help me out. Go ahead. What's the name of this 3-dimensional figure that we've got? It is a pyramid because it's got one base and then ends in a vertex at the other side. What kind of pyramid? Is it a rectangular pyramid, a pentagonal pyramid?
A rectangular. Or wait, no. It's like a triangle.
Perfect. It is a triangular pyramid. Liam, what part do we have to look at to see what kind of pyramid it is? Do I have to look at like a lateral face or an edge, or what do I have to look at to see what kind of pyramid it is? Yeah, gotta look at the base. All right, I see that the base is a triangle, so that means that it is a triangular pyramid. All right, so we know that this is the 3D figure, That's our 3D figure. Alright, James, what's our plane? Which thing in this diagram is our plane?
I don't know what color that is, but it's the shape that's not the triangle.
This thing?
Yeah, I'll say the
Yeah.
triangle.
It's like a tan orange. Yeah, so that's our plane. Alright, so Delia, this is the 3D figure. That's the plane going through it. What's the cross section that's formed? What shape is that?
Like the whole thing? Or just like the shape?
Yeah, what's the shape that's formed by the cross section? So kind of going back to it. We had a plane intersecting this rectangular prism. What shape was this cross section? Rectangle. Alright, so Ansley, what is the shape formed there? What's the cross section in part A?
A triangle?
Yeah, absolutely, guys. It is just a triangle. Alright, so literally all you're doing when you're describing each cross section, you're literally just saying what shape is formed. Oh, I missed that a little bit. Alright, what shape is formed by the intersection of the 3D figure and the plane? Alright? Yes, sir.
So when you have your 3D figure and you put the plane like straight flat, wouldn't it just be a mimic of this?
Yeah, yeah, often, if not always. So yeah, no, that's a great question, guys. If your plane is horizontal to your base, like this one is, or like parallel, basically. If it's parallel to your base, yeah, it's gonna mimic whatever the base is. Yes, sir.
Can you check if this is right?
For which part?
Right here.
Oh, when we get there. When we get there. Yeah. All right. So let's go ahead and keep going. So guys, go ahead and do part B on your own. Identify what shape is that cross section.
I'll put a rectangle.
Yeah.
Imagine it rotating into like a circle.
Yeah, absolutely. What did you think?
I thought it was rectangle, because it's like a rectangle. But is it
Where's the
like this part?
That's the plan.
Oh,
So that's the plane.
This
So what you're looking at is you're looking at a shape that's formed by the plane when it intersects with the shape.
Yes.
Just like can you trace the cross section in here for me? See, that's not the cross section. What's that? There we go. That's the cross section. All right. So first up, guys, let's go ahead and come back together. All right. First off, someone tell me what is the plane here? Let me hear from Mariana. Yes. All right. So guys, this is our plane. This is not our cross section. That's our plane. And what is the three-dimensional figure that we are intersecting? Airless? What's this called?
Oh, it's just called the cylinder.
Yeah, so that's our cylinder. That's our 3D figure. Alright, 3D figure. Ugh, that's an R. Alright, so now, what is the shape of our cross section? Let me hear from Alex. Yeah, it's a circle. Alright, there it is. That is our cross section. It is a circle, and that is our answer. Any questions on that? Alright, so now guys, let's turn up the difficulty a little bit. So now guys, we're not going to be provided the image. We're asked, if we turn the orange planes into vertical planes, right now they're horizontal. If we turn it into vertical, what would the resulting cross sections be? So I'm going to give everyone a second to think about this. Alright, so what would the resulting cross section be if it wasn't,
What's up?
if it wasn't, let me go ahead and get this. If it wasn't horizontal anymore, but if it was vertical instead.
Yeah, so A is a triangle.
Yeah. Alright, and so for this, guys, I actually have a video for us to check out a little bit.
The first one.
Brought to you by.
For some reason, I still think the first
Could you get the lights
Well,
for
that's
me?
shape too.
Thank you, sir. Alright, guys, so, thank you. Alright, so here we go.
I know the answer, but.
Oh, come back.
Oh, I do too. No, you don't. No, you don't.
Doesn't matter what triangle it is.
Nope.
Alright, so guys, what we're looking at,
Three sides is considered a triangle.
here we go.
Yeah. But
What we're looking at, guys, is she's going to take Play-Doh. She's going to take Play-Doh and she's going to slice it in half. Alright, so she's taking a knife and she's making a horizontal, she's basically using that knife as a horizontal plane. And then the cross section ends up being a triangle. So that's the one that we just did.
Yep.
Now, guys, she's going to take, now she's going to take her knife and she's cutting it vertically. She's taking that triangular pyramid and she's cutting it vertically, a vertical cross section, or a vertical plane. And we end up seeing that
It's a triangle.
the cross section is a triangle again. It's a different shape of a triangle, but it is indeed still just a triangle. All right.
Fitzgerald.
Look, Saudi, you.
Thank you.
All right. So guys, let's go ahead and go back to this. So yes, it is going to be a triangle. And let's go ahead and look at part B. So again, if you were to take this cylinder and instead of a horizontal plane, you used a vertical plane, what would the resulting cross section be? Let me hear from Diska. It is going to be a rectangle.
Mine.
Wait.
Whoa.
Alright, and we can go ahead and see that
Circle
here.
again.
Set the triangle in a circle.
Alright, so here we have a horizontal cross section, you form a circle. A diagonal one, form an oval. But if it is straight up and down, you form a rectangle. And here's kind of another picture so you can kind of see it.
Oh.
Alright, imagine you take that cylinder, you slice it long ways, and you get that flat rectangle surface.
Oh my
Rectangular surface.
Alright, Brandon, the next one.
Alright, any questions on that, guys? Yes, sir.
Can I go to the bathroom? It's an emergency.
Yes, sir.
finished all
You're like-
Yeah, he
Oh,
already
this
did
is
everything.
this is the part that you're asking about. But yeah,
No, actually, no. I fixed it for him. It's a
You can go.
comb. It's a comb.
I got it.
Can we speed run this part?
Speed run.
So I can do the homework?
Yeah.
Yeah.
Alright, so here we go, guys.
Dance, bro.
Looking at the two-dimensional figure and a line of rotation. So now, guys, what we're going to do is we're going to generate our own three-dimensional figures. We're going to take a two-dimensional shape and rotate it about this axis or line of rotation. So the process for doing this, guys, is take basically each point in your mind or sketch it, and you're rotating it 360 degrees around this line of rotation. So you're imagining every single point along this shape, this right triangle, rotated. And I've got something to show you a little bit. So obviously, guys, this is two right triangles stacked on top of each other. What shape is going to be formed if I rotate this 360 degrees?
A diamond.
That's a diamond.
It's going to be
A diamond. Oh.
two cones stacked on top of each other.
So you already gave the answer.
And so
already.
one of
You
them,
already gave the answer. already.
one of them would just be a single cone. And y'all thought those decorations were just for show.
Oh my goodness.
Mind blown, huh?
Wow.
Wait, it'd be considered a, oh.
And it kind of, you can kind of see that it's kind of created for you. You know, if you go ahead and connect this dot,
Yep.
imagine this rotated all the way around, you can kind of see the cone right there. So guys, go ahead, try and sketch a cone. Fair warning, trying to sketch a cone can be a little sketchy.
It's actually not that hard. Mr. Toddy,
Yes, sir.
what would the properties be to make like a pyramid in a rotation? Is that even possible?
No.
No.
Because think about it. It's gotta have some kind of like round element to it because you're
Oh.
rotating it 360 degrees in a circle.
This one confused me.
What are you confused about?
Well, for a second I thought we were looking at the shape from the top. You know? And it was like a pyramid, a triangular pyramid.
Okay. I'm not sure I get what you're saying. What are you saying, Christian?
I thought that was like the triangle right there, the right triangle, like was the base of the shape. And we're supposed to go up.
It would still be a cone, but just sideways.
like
You know what the Pentagon?
Like a point in the middle of the triangle.
here.
Like so here. Like this, and we're viewing it from above. And it's like that. I don't know why I thought it was like this.
I know what a Pentagon.
He thought he thought
I don't know why.
He doesn't know how to count.
It's still a cone rotating.
Alright, so can someone tell me why did I erase these parts to kind of make it dash in the back? Xavier?
Because you can't see it, like, you can't really see it if you're looking at it.
Right, so guys, with a cone, unless it's see-through, you can't see that back line. So that's kind of why I did that. Alright, so, guys, you actually here. So real quick, here's another video for you guys. We're going to go ahead and see. Alright, go ahead and watch this illustration of this right triangle is going to be rotated 360 degrees around this axis or line of rotation.
Is this gonna be on the test?
And there it is.
That's crazy.
You can see how it created a cone.
Is this gonna be on the test?
This concept will be for sure.
Cause I can't draw.
You're not gonna have to draw. Not gonna have to draw
All
the
the
test.
tests are
James can't really do much.
Alright, so guys, go ahead and work on your own sections. And we'll come back together in a few minutes to go over them.
Question.
After the line.
Like this, it's only a quarter.
Oh, yeah.
Think about it.
Just like, no.
Right here.
How about this
So what shape would it be?
Figure.
So
It's a rectangle.
maybe a rectangle.
Okay.
Think about it.
I know.
So,
Literally
you
draw
absolutely have to go right now.
3 circles.
Yeah.
Another circle and then just
So
draw.
think about it this way, guys. If I took this and I rotated
Draw
it
a.
all the way around, sorry.
Yeah.
And this is my axis of rotation. What
Huh?
am I forming here?
Rectangle.
Think something with a circular base.
Oh, yeah.
Yeah. Yep.
So wait, that's what I draw?
Yeah.
So,
Yes, sir. Oh, what was this one?
this thing is cylinder.
We'll see something that, give it a sec, I'll put something out for it. You guys, if you're already done, feel free to start working on the homework.
Oh yeah.
I see everyone about done. So guys, let's go ahead and bring it back together. Alright, so describing each cross section. Alright, so here is our plane. Alright, that's our plane. This is our 3D. I didn't draw that arrow very well. This is our 3D figure. Alright, and then so what is the shape generated by this intersection? Carolyn? What is the shape generated by the intersection of this plane and this 3D figure? Say again? Hexagon. Yes, it is absolutely a hexagon. All right. We can count 1, 2, 3, 4, 5, 6 sides. It is a 6-sided figure, so it is a hexagon. Awesome job. All right. Let me hear from Joseph. What is the cross section in part B?
Cross section?
Yes. So like here's our plane. This was our 3D figure. What is the shape of our cross section?
Triangle?
Yes, sir. It is a triangle. Alright, and last part, guys. So, again, try and draw it. So, we have this rotating around 360 degrees. Imagine every point rotated around 360 degrees. And what shape does it end up being, Liam? A cylinder. Alright, and it kind of draws it for you. Alright, so let's go ahead. We've got 2 lines.
Thank you.
And then,
Yeah, I didn't notice.
and that is our cylinder. If I do say so myself, I'd say it's a pretty solid shape. Solid drawing. Alright guys, so
Figure.
guys, the rest of the class is yours to work on the homework. Real quick, before you guys move around. For 1, 2, and 3, please take note. It doesn't just say to classify each figure. It says name the vertices. Guys,
That took way too long.
before you move around, name the vertices, name the edges, and the bases, alright? You're naming edge, segment XT, segment WX, segment ZY.
Mr.
Alright, so
Katani,
guys, go ahead and get working.
you made us write way too much on that cube. You made us write way too much.
Oh my gosh.